Mm. Okay. Yes. So we have been doing Heron's formula. Can anybody tell me quickly what was it exactly?
Ma'am, please do perimeter of all the shapes today.
We are going to do what, Patrick?
Ma'am,
Perimeter of all the
the area and perimeter of all shapes today. Ma'am, we finished Hero's formula.
but I haven't tried a question with you for the same. So that we are going to try out today. Okay, a question with this formula we are going to check out. And in the coming classes, we'll do the area and perimeter of all the figures. Okay, S, S minus A, S minus B, and S minus C. Now, my question, suppose it says that find area of triangle. Find area of a triangle whose sides are 25 centimeter, 60 centimeter, and 65 centimeter. Okay. So we have a triangle whose sides measure 225, 60, and 65 centimeter. What's the first thing that we do? We find out the value
Yes.
of,
Yes.
yeah, that is the first thing we do. So let's find out the value of x. S, what is the formula? S is equals to A plus B plus C divided by,
Ma'am,
yes, Cedric,
ma'am, is it 75?
75. Yes, it's 75. So let's add them up. 25 plus 60 plus 65 by 2. We'll add them. We'll get 150 by 2. Okay, divided, we'll get 75. Okay, so our S here is 75. Now we are going to put the Heron's formula here. Okay, we are going to put the Heron's formula. 75. 75 minus 25. 75 minus 60. 75 minus 65. Okay, now subtract them first. Subtract all of the values first. We will get 75 into 75 minus 25.
50.
50 into 75 minus 60.
15.
50 into 75 minus 65.
10.
10. Okay, so we have all the values. Now in this step, what we do, we take the HCF, okay, of all the numbers and make them into factors. Okay, we will make them into factors. So take the HCF of all the numbers and obtain the factors 75, 50, 15, and 10.
Ma'am, so it will be 3 into 3 into 25 into 25 into 2 into 2 into 5 into 5 equal to Ma'am, it's 750.
750? Right. The answer is 750. So I have the HCF of 75. Now let's take the HCF of 50. 50. Do it with 2. 2, 25. 5. 5 is 25. 5. 5 is 5. Okay. 50 is done. Now let's do of 15. 15. 3. 5 is 15. 5. 5 is 5. Then let's do of 10. 2. 5 is 10. 5. 5. Okay. So we have all the factors. Now we will write them here. We will write them 3 into 5 into 5 into 2 into 5 into 5. Then for 15 into 3 into 5. For 10 into 2 into 5. Okay. Now we have all the factors. Now we will make pairs. Okay. We will make pairs 3 and 3. Okay. 2 and 2. Okay. Then what else do we have? 5, 5 here and 5, 5 here. Okay. And 5 and 5 here. Okay. So we have 3 pairs of 5, 1 pair of 2 and 1 pair of 3. So that way we will take them one out of each pair. Okay. Look how. Now 3 from, okay, let's start with 2. You start with a smaller number. Okay, 2 from the pair of 2, 3 from the pair of 3, 5 from this pair, then 5 from this pair, and then 5 from the last pair. Okay, so we have 2 into 3
Only
into
one
5
from each pair.
into, yes, 1 of each pair. Okay, now solve it. Multiply these.
Ma'am, we get 750.
Yes.
Ma'am, how come there's square root over there? Should not be square root, ma'am. Down last one. Should not be.
Yes. Okay, so multiply them and we will get the answer 750 centimeter square. Why? Because it's an area. All right. So once again, firstly, we will check the measure of the sides. We take those sides, add them, divide by 2. Okay. Because we are finding S, that is semi-perimeter. Okay. S semi-perimeter. How do we find the perimeter? We add all the sides. Semi-perimeter, add the sides, divide by 2. We get the S. Now we have the S, we have the measure of all the sides, put them in the formula. Okay. Side S. Okay. Then that semi-perimeter minus one side and semi-perimeter minus the second side, semi-perimeter minus the third side. Okay. First we do minus, then we multiply. All right. So first we will minus them from the semi-perimeter, minus all the 3 sides from semi-perimeter. Okay. We will obtain 4 numbers. One is the semi-perimeter. Other 3 are the multiplication answers. Okay. Of the 3 sides. So then take their HCF. Okay, take the factors, find, make pairs, take the common, okay, and then find the answer. Yes, Abraham.
Ma'am, do we use Heron's formula, ma'am? Is because in some shapes the regular formula that we use for like if we want to find the area of a pentagon or a dectagon, that may be difficult, and we don't want to split it. Do we use Heron's formula in that case?
Do we use Heron's formula in that case? Abraham, I don't think we use Heron's formula where we have a pentagon or decagon or something.
No, ma'am, is because if we have Heron's formula, we can divide the pentagon into, yeah, we can find its perimeter uh,
Mm-hmm.
by plussing all of them and then divide the perimeter by 2, and then we can just do the same thing but with 10 boxes. It would give us the area, it would give us the same answer, right, ma'am?
It would give us the same answer, probably, but I
Ma'am,
will find
we
it
can
out.
also do it for square also. Ma'am,
Yeah,
we can do
the
for square.
same terminology is used to square, but it would be better used for a
Yes.
dectagon because a dectagon is more difficult to calculate using the normal formula.
But in decagon, you need to use 10 of this thing. S minus A, S minus B, S minus C, S minus D, S minus E, S minus F, S minus G, S minus H, S minus I, and S minus J. Till J to be there.
Uh,
Yeah, that is the thing. It's going to
but,
be a mm,
but the only
lengthy.
but the only problem, ma'am, with this formula, you can only do till 26 sides.
No, 25. 25, not 26. Because S is not there. No.
25.
Okay, alphabetically by the counting. All right. So, but again, it will be a lengthy process if you use this formula for those all the figures with more sides. If you want to use this formula, it's going to be quite lengthy, and there are formulas derived, okay, for each of the shapes. For most of the shapes, that is, we have separate formulas that we can put. Okay, now I'm going to give you all one question to try using this Heron formula. Okay, write this down and then we will see that.
I'm writing on.
I'm writing.
Done.
All of you all that right?
Yes, ma'am.
Fine. Okay. So I'm clearing it. Try out this question. Write this out.
Ma'am, is it 54?
Yes, Cedric, that's correct.
Ma'am, is there also 54 centimeters square?
Yes, Anaya, that is right. Okay, Sunny and Zaya, how is it going?
Good, ma'am.
Ma'am, it's going good, ma'am. I'm almost done, ma'am. I just have to calculate after minusing 18, and then I just have
Hmm.
to multiply all the numbers with. I have to multiply all the numbers.
Okay, take your time, do it. Sunny, and how is it going? Okay, you are going to finish it and then we will discuss. Okay. Okay, let's discuss this. Now, first we'll find out the value of S. Very important thing that I always tell you all is while you're solving, write the formulas, okay? Write all the formulas while you are solving them in every question. Okay, so it won't be wrong. You will learn the formulas also and you will use the writing also. Okay, so never skip writing the formulas while solving the question. Okay, now we have 9, 12 and 15 by 2. What is the total?
36 by 2.
36 by 2. Now 18. Okay, we have of 36. Now we will use the Heron's formula, which is area equals to root S minus A, S minus B, and S minus C.
Ma'am, I have a question, ma'am.
Yes, Abraham.
Ma'am, ma'am, what number do we root?
What number do we root? Abraham, what happens after we have calculated the factors? Okay, we have the factors. Then we will find the common. So now when we have taken the common, our root will be removed. Okay, that is one thing to remove the root. Then you just multiply and we find the answer. Okay, when we are making the pairs of the factors, when we take them out, one out, the root is removed in that last step. Okay, last second step, and then you just multiply and find the answer. All right.
Okay, ma'am. Ma'am, but
Yeah.
I'm getting 269, 2690.
2690. Okay. All right. Let's see where you missed this step. 18 minus 9. Okay. Then 18 minus 12 and 18 minus 15. 18 into. What is 18 minus 9?
9,
9,
18 minus 12.
6,
6,
18 minus 15.
3.
3.
3. Very good. Now do the HCF of 18, 9 and 6. Okay. Because 3 it will come as it is. All right. It will come as it is. It's a small number. All right. We'll do the HCF of 18, 9 and 6.
Ma'am, the answer is
18.
2 into 3 into 3 into 3 into 3 into 2 into 3 into 3.
Yes, that is right, Maya. 18. Let's do it with 2. 9 by 18. 3 3s are 9. 3 1s are 3. We have 2 into 3 into 3. Now let's do for 9. 9 3 3s are 9. 3 1s are 3 and 6. 2 3s are 6. 3 1s are 3. Okay, so let's write these. 2 into 3 into 3 into 3 into 3 into 2 into 3 and one more 3 by for this 3. Okay, as it is. Now make pairs.
2 into
2
3
into
into 3 into 3.
yes, then 3 3 and 3. So we have 2 into 3 into 3 into 3, 2 into 3 into 3 into 3. Multiply them. Okay,
54 centimeters.
Yeah, 2 threes are 6, 6 threes are 18, 18 threes are 54 centimeter square. Okay. Abraham, you found what went wrong? Okay. So here in this step, Abraham, we remove the root. Okay, because we take common out of the factors, our root will be removed and we have to simply multiply them. Okay, we have to simply multiply them to find the area. Hope the Heron's formula is clear to you all now. Okay. Any questions, any doubts? Sydney and Zara, hope it's clear. Okay. All right. So, have you all written? Shall I move on to the next part?
I've written mine.
Done, ma'am.
Okay.
Finished copying.
Okay.
Also done.
Okay. Let me open the book 1 second. Okay. So we have area of a triangle with the help of graph paper. Now, in in questions such as these, you guys will be given the triangle. Okay, you will be given the triangle on the graph paper. What you have to do, what we will do, is we will find out its area. Okay, how are we going to find out its area? If you look carefully at this diagram, we can see that there are two like the squares of the graph paper. Okay, we have the squares of the graph paper. Now there are some squares which are totally inside the triangle. Okay, which are fully inside the triangle. But there are
Ma'am,
some
they count as
squares.
one. They count as one.
Yes, but there are some squares who are only half in
They
who
count as
are only
half.
half
They
inside.
count as half.
Yes, Edric, 1 second, let me explain it first fully. Okay, so those triangles, okay, only half part is covered. All right, only half part is covered inside the triangle. Rest is outside the boundary of the triangle. Okay, so all of these squares they made up our triangle. What we do first, we can count how many squares are there which are completely inside our triangle. How many squares are there which are completely inside the triangle? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, 12 squares we have which are completely inside the triangle. So we write number of complete squares or shaded, that is 12. Okay. Then we see how many of the incomplete squares are there. Okay. How many incomplete squares are there. Okay. So let's see them. We have 1, 2, 3, 4, 5, 6, 7, and 8. Okay. 8 squares which are half shaded. All right. So what we do, 8 squares are there which are half shaded. All right. So we can write incomplete squares are 8. Now each incomplete square, like Edric said, is half. Okay. Each incomplete square is half. So what we do to find area of such a triangle, we take the complete squares. Okay. We add in that the half of 8. Okay. The half of 8. Alright. Why? Because the 8 squares are incomplete. Okay. So we do 12, that is complete squares, plus half into 8. That is incomplete squares, the half part of the incomplete squares. So we will have an area that is 16 centimeter square. Okay. Hope it's clear to you. And I am disconnected. Okay. So now moving on. Now this is one part of it. Okay. Where there are fully shaded squares or half shaded squares. What if? What if we have squares who are shaded, which are shaded like this? Let me do the black one. Who cover inside the triangle only this part. Okay, this is not even half. Okay, or if we have squares which complete portion like this, inside the triangle, portion like this inside the triangle, this is more than half. Okay, this is more than half. So what do we do with these squares? How do we count them then? If that is covering, okay, if we have a square that is covering more than half portion inside the triangle, or only less than half portion, only this much portion inside the triangle,
Ma'am,
what do we do with them? Yes,
ma'am,
Edric.
when more than half is covered, it is counted as 1. When less than half is covered, it is counted as 0.
Yes, that is correct. Okay, so when we have shaded box, a shaded square inside a triangle, which is shaded more than half, okay, which is shaded more than half, we count that as 1. Okay, complete one. We will assume that this is fully shaded. Okay, that this is fully shaded. We'll assume that. But if we have squares which are shaded less than half, we will assume that this is not shaded at all. 0. Okay, we'll assume that it is 0. So now look at this figure. Look at this figure. We have fully shaded squares. Okay, if you take a look at this square, okay, this one, in this one, only less than half portion is covered inside the triangle. Whereas if you take a look at this one, more than half is covered inside the triangle. So this one we will take 0, whereas this one we will take 1. That is fully shaded. Okay. Then we have this one also we will take as 1. Okay, this one, right? Because more than half part is inside the triangle. Whereas this one we will take as 0. Why? Because less than half portion is there. Then we have this one also we will take as 0. Less than half portion is covered. Okay. So hope you are getting now that how are we going to count these. Okay. So let's do
No, less than half is
here.
0, more than half is 1.
Yes, that is right, Edric. Half is considered half. Okay. But more than half we'll consider it 1. Less than half we'll consider it 0. Okay. Now let's count them. Firstly, let's count how many are fully shaded or fully covered. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. We have 14 fully shaded squares. So we can write number of complete squares. How much? 14. Okay. 10 incomplete squares which are half. Okay. We will check out how many that are half. Okay, we have
Ma'am,
1, 2, 3, 4, and 5. These are
ma'am,
exactly, yes, address.
ma'am, there are 15 complete squares, not 14. There are 15.
There are 15. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, there are 15. I think there is a mistake here, corrected. 15. Okay. Now, out of this 15, that one I was thinking, I think I counted 15, but it's mentioned 14. I thought I must have made a mistake in counting. Yes. So, now,
Ma'am, you didn't make a mistake in counting, ma'am. Ma'am, Edric's counting, I think, for all the shaded squares. But one square, you can see that it's little out of the triangle line. That's why maybe they said 14.
mm-hmm.
The square to
Okay.
the right hand side, a little
Okay,
out.
yes. Mm-hmm. Yes, Abraham, I can see. Yeah, right. So, it is 14 only. Again, okay, it is 14 only because this one is a little out, okay? It's not like fully
Yeah,
covered.
ma'am. Yeah, ma'am, that one is a dot. Ma'am, that one has to be a dot, ma'am, and not shaded. That one has to be dot.
Yes, yes, Patrick, yes, that is right. So this square that we are talking about, okay, this one, okay, that is only a little bit is not like shaded, okay. But first we will count, okay, do the separation first, okay, while you are solving, separate them first, all right. How? Firstly, we have taken the complete squares 14, which are fully inside the triangle. Then we will take incomplete squares, which are half inside the triangle, half outside. 5 are inside, okay? Half inside, outside. We have 5. These 5, okay? The tick ones. Then, number of squares more than half, okay? More than half. Let's see the ones which are more than half. We have this one, okay? More than half. Then we have this one, more than half, and we have this one, that is more than half. Okay, these three we have more than half. Okay, then number of squares less than half. Less than half. Let's see, is this one. Okay, less than half. Then there is this one, less than half, and there is this one. Okay, less than half. So these three we have which are less than half. Okay, so now we will add them up. First, we will do 14, okay, that are completely shaded. Then half into 5. Why half into 5? Because 5 are only half shaded. Okay, 5 are only half shaded. So half into 5. Plus 3 into 1. These are fully shaded. 3 are fully, okay, not fully shaded. These are more than shaded, more than half. Okay, covered inside the triangle, more than half. So what I said, when we have the square which are inside more than a half, we take it as 1. 3 we have, so 3 into 1. Okay, then 3 are there which are shaded very less than half, okay, which are shaded lesser than half. So for those, we take them as 0. So for that, they have done 3 into 0. Okay, 3 into 0. Those we take as 0. So now, then we solve it. 14 plus half into 5 is 2.5 plus 3 1 that's 3. You add them up, 14, 2.5 and 3. You will get 19.5 centimeter square. Okay, 14, 15, 16, 17, 18, 19.5. Yes, 19.5 centimeter square. Yes, Abraham.
Ma'am, I have a question.
Yes, ask.
Ma'am, this will only come to the approximate perimeter, right?
This will only come to the approximate perimeter. Abraham, I think so.
Not a perimeter area.
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 Area, yes, right.
Ma'am, the
Approximate
reason
area,
we want to find
probably yes.
exact area is because normally square grids are 1 centimeter to 1 centimeter and 1 centimeter because they are square. They are normally that much on the graph paper. So we can take our ruler and then measure them, measure two sides together, and then multiply them, and then divide them by 2.
Okay, that is half base into height formula you're talking about.
Yes, ma'am.
Okay.
Then we'll get the
All
exact.
right. Okay, so do one thing today. Well, I'll be giving you all homework for this exercise. Homework for 16.2. Okay. These figures, you have to draw them in your graph paper and check, or you can just check from here as well. Okay. So if you draw them on your graph paper as it is, these diagrams, okay, take like four blocks are there, draw four blocks, then count the number of blocks, draw a line, then measure the length of the line, and then try to find out with the half base into height formula and check. Okay, compare both of the areas. Okay, try out this activity at home today. Okay, you can try out comparing both of these areas to see like how much difference is exactly coming in both the areas. Remember when in the starting of the chapter you guys asked me how did you find the area of an irregular figure, irregular shape? Like I said that they divide it into regular shapes. Okay, the area that he can find out. They use the square and everything. So this is how. This is quite similar to that, that they are using the square. Okay, since the square is the unit of measurement for area, we divide the whole piece, okay, into squares. So if the like in the edges, if there are squares who cover more than half of the area, they count it as one. If they cover lesser than half of the area, they count it as zero. Then they calculate from those squares and they find out its area. Okay, this is the technique that I told you all in the beginning. Okay, so these are you're gonna do this for the homework. Okay, then try out the fill in the blanks, try out the Heron's formula, this question, and Heron's formula. Okay. Find the area, base, and height you are given. You can try the second also. I've taught you all the base into height formula too. Okay, so we can try this out. Okay, this question, third question, don't do yet. Okay, do the first, second, and the fourth question. I will teach you how to calculate the height when area and base is given, how to calculate base when area and height is given in the next class. Okay. We will learn about this. Today's homework is the first, second, and fourth question. Okay. Clear? Any doubt till now?
Yes, ma'am. Ma'am,
Abraham?
the grid that is there, ma'am, when I try measuring it with my ruler, ma'am, it is showing 0.5 on one square. But then as it progresses, it is going off the charts now. Is it that my ruler is faulty or is it the grid is faulty?
Can you repeat what's happening once again?
Ma'am, I'll just show you.
Mm-hmm. You were measuring from the centimeter side, Abraham,
Yes,
right?
ma'am. It's supposed to be 0.5, ma'am. It's 0.5 here. Then it goes 1, 2, and then it comes off. Is
It comes off. Okay, Abraham, what you can do is, while they view this grid, I'm not exactly sure. This is like smaller than the actual grid that is there. Draw the same figure in your graph paper and then do. Okay?
okay, ma'am.
Yeah.
And
Draw
ma'am,
the same.
or could
Mhm.
my ruler be faulty?
Can the ruler be faulty? Try using another ruler if that is the case. I don't really know about your ruler, so try using another ruler, okay? And see. All right, so we will stop here and we are going to meet for the next class. I've told you all the homework 16.2, question 1, 2, and 4. Okay? Okay, then. Thank you, Abraham, and I. Bye, guys.